Now I would like to get you introduced to our first keynote speaker. Please welcome to the stage Zane Ball from Intel.
Soren.
Hello, Zane. Good to see you. I heard this is your first time here at CloudFest.
It's my first time in CloudFest.
Okay.
And it's my first time in Europe since 2019, so I'm pretty pumped up.
Okay, great. Good to know. Where are you from?
I'm from Oregon, USA, Portland.
Portland, very beautiful. How did the team brief you? I mean, this is such an unusual event. Like, what was the briefing you received?
Well, they did tell me it was very serious and that a lot of preparation was going to be required. There was a whole training schedule. Last week, there was 1 beer on Monday, 2 on Tuesday, 3 on Wednesday. I think by today, I'm almost ready, but we'll see. I'm looking forward to this party.
Okay, perfect. Okay, the stage is yours, Zane. Enjoy it and have fun.
Awesome. Thank you very much.
Thank you, Zane. Mm-hmm.
All right. It is great to be here. This is a fantastic event. I was looking at the agenda and so many interesting attendees. I'm looking forward to really learning a lot, and especially getting that European perspective on where we're going with the data center. I wanted to spend a few minutes this morning talking a little bit about the future of the data center and where we're going with cloud computing together. In my view, there's 3 really important things that we have to accomplish in the next few years. The first, and I think really defines the cloud and cloud computing, and that's scalability. Together in this industry, we are creating a kind of illusion. We're almost like magicians. We're creating the illusion that computing is infinitely available and infinitely scalable and at an almost negligible cost to society. And society is just building more and more services, more and more of the economy on top of the infrastructure that we provide. And so that's a huge responsibility for us. And as we do that, and as more of the world's economy runs on top of our infrastructure, we first and foremost have a huge responsibility for the security of that data and information. I'm not going to speak much about security. My colleague Marcus has a keynote tomorrow that's going to go into great depth about security, as I know there are a number of sessions here at the conference on that topic. And then finally, we have to recognize the sheer scale of our industry and the environmental impact that we have, and we really have to focus on solutions to improve sustainability of data centers. And that's really what I'm going to spend most of my time talking about today. With climate change, the imperative of energy efficiency is extremely important, and I think really needs to be at the first position in our minds. So I'd first like to call out our track record. Our track record on energy efficiency as an industry is actually quite good. There's a study published in Science in 2020 analyzing in detail energy efficiency of data centers from 2010 until 2018. And their discovery was that energy efficiency improved by a remarkable 20% per year. 20%. That's an astounding achievement, and really an order of magnitude better than any other industry. And so we should really be proud about that, even as we're recognizing that there's a lot more to do in the future. And what was, I think, most interesting about this study was sort of understanding where these remarkable gains in energy efficiency were coming from. I think it's really important that we learn from those so that we can plot the course for the future. And so the first and kind of most obvious one is Moore's Law, right? We are improving semiconductor technology for the last 50 years, doubling the number of transistors every 2 years, reducing power, increasing performance. Today that looks like more CPU cores and more capability on semiconductors. But that is not the whole story by any means. Moore's Law alone does not explain the 20% reduction, and nor is it sufficient for our future. So there were other pieces as well. And the second piece was the efficiencies gained in the move to hyperscale data centers. And I thought this was particularly interesting, that the savings in power and cooling associated with these more efficient large-scale installations more than made up for the increase in compute that was being deployed. And so the reduction in PUE is, today it's not uncommon to see a data center with a less than 1.1 PUE. Those changes have really been important. Finally, there was virtualization. So if you go back to 2010, virtualization maybe wasn't so important in the broad adoption, but today it's ubiquitous. And virtualization drove much more efficient use of resources, and was a very significant part of this story. So we put these three things together. It's kind of easy to see that Moore's Law is going to continue with a little bit of work and investment. The move to hyperscale, to some degree, has already happened. Can we really count on more efficiency gains there? And virtualization, well, that story's kind of done. So we've got to replace our virtualization gains with something new in the future. And so giving a little bit of thought to this, I think we can really break down the sustainability problem into progress that we need to make on each of these three vectors. So first, the most obvious one is, of course, Moore's Law. And at Intel, we're investing billions and billions and billions of dollars in advancing process technology. We intend to deliver 1 trillion transistor devices by the end of this decade. We intend to deliver 5 process nodes in just 4 years. We're pushing the development of Moore's Law, if anything, at a faster pace than we've done in the past. So I think we can continue to count on Moore's Law to deliver its piece of the puzzle over the next several years. But again, that's not enough. What about the role that hyperscale efficiency played? I have 2 thoughts on this. Number one is it's more than hyperscale. We really need to challenge ourselves for edge deployments, especially because that part of the market is growing so fast. We need the edge to be as energy efficient as the hyperscale. And I think there are good options to make that happen. And hyperscale itself has to continue to innovate. And in some of the work we've done in partnering with our customers, I've seen enough technical data to believe that it's absolutely possible. One of the areas I'm most excited about is the emergence of liquid cooling and immersion cooling technologies being taken more seriously. I think some of those will be displayed here at CloudFest. In the research that we do in our own labs at Intel, we've seen performance per watt improvements of over 20% without really changing the architecture, without deep optimizations. We really see the benefits of these technologies. There's also the ability to optimize how power is staged and delivered in data centers with AI technologies, and I'm sure there's 100 other innovations that need to be pursued. But make no mistake, the physical infrastructure will need to significantly improve in the next years. And finally, and I think this is the area that I want to focus on the most, is that virtualization replacement. What's going to play the role that virtualization did in the last 10 years? And I would like to introduce a concept to you called hardware-aware software. When hardware and software collaborate at a very deep level, we have the opportunity to see really outsized gains. And the most obvious version of this is fixed function acceleration, which I'm having a little hard time getting it to move forward. There we go. We can achieve remarkable gains in power performance and energy efficiency when we use accelerators. And the regular incremental improvements that we get every generation with general purpose performance aren't really going to get us to the energy efficiency goals that we need to hit to play the role in society that we need to play. And I believe that acceleration is one of the most important things we can work on right now. But it does require a little bit of a change in our mindset. Software can no longer simply just take hardware for granted. You program any way you want, any kind of language that you want to program in, and you just ignore the consequences. You actually have to collaborate software and hardware together, and then we can get remarkable gains. So if you're following me, I'd like to show how our latest platform from Intel is really advancing the capability on each of these 3 vectors. We just recently launched the Intel 4th Gen Intel Xeon processor in January. And we've spent a number of years working on the design, and it has a lot to offer in each of these 3 domains. And the first, just extending Moore's law, really what you expect from a microprocessor, delivering more cores, more memory bandwidth, more I/O bandwidth, and driving the power performance curve. So we deliver 53% performance gain in general purpose performance on average. So this is awesome. And I think really is a remarkable improvement over the prior generation. But as awesome as that is, it's, again, on its own, really not enough to really get the kind of breakthroughs in energy efficiency that we really need to see. So the second thing we worked on was looking at how systems are deployed in large-scale systems, hyperscale in particular. We've partnered for years getting into the real details with our customers on how their data centers are loaded, how workloads are managed, what the latency sensitivity of those workloads are. And we found that we can craft recipes with deep sleep and power states in the architecture to really optimize power consumption. Now, up until now, these kind of tricks were pretty complicated. They required a lot of investment, a lot of work, a lot of engineering time. And what we realized that the world needed for broad application was an out-of-box experience. We needed an easy button for power efficiency. And so that's what optimized power mode in 4th Gen Xeon processors represents. You just turn it on, no tuning, no deep technical knowledge required, and it will give you up to about 20% power reduction. Now, in some workload cases, there may be some small performance impacts because we are kind of trading latency to power states off against that power savings, but these are generally quite minor, less than 5%, maybe way less than 5% in many cases. So it's an easy button for very significant power savings. And so right out of the box, we can deliver more performance, we can bring power under control, and we can really advance this energy efficiency opportunity. But that's not all. What the 4th Gen Xeon processor really represents is a major pivot into acceleration, and acceleration to deliver that kind of hardware-aware software opportunity that we had with virtualization, but now geared for the future. And so we productized 5 new accelerators in the design, and I think they're very significant for advancing power efficiency. And we chose these accelerators carefully based on what are the fastest growing and most important workloads in the cloud today. And I hope you agree with me, the workloads that we focused on are on this chart. AI, data analytics, network and 5G, storage, and even HPC. And we delivered significant gains across all of these. And I'm going to share a couple of these in a little bit more depth. First, let's take a look at the performance. The biggest gains come in artificial intelligence. So the accelerator we have with AMX, which I'll talk about a little bit more in a second, really is a big investment of silicon resources in driving these AI-type workloads. We've delivered acceleration for network and vRAN applications, doubling performance, networking and storage, doubling performance, think 95% fewer cores for certain activities, tripling data analytics performance. And even in HPC, thanks to our high bandwidth memory Xeon Max series, we're able to deliver 3.7 times performance on memory-bound workloads, which in many cases, those are very significant. So if we just sort of looked across all of those workloads at a rough average, this acceleration project is delivering a 2.9x performance per watt improvement. That's the kind of substantial gains in energy efficiency that are really going to take us somewhere. But again, it does require some additional investment from software. Intel has spent significant resources doing software enabling, especially in AI, enabling common frameworks, and working with partners throughout the ecosystem to make this practical. I don't have a lot of time today, so I thought I would dive into 2 of these accelerators in just a little bit more detail. So the first one I wanted to talk about is Quick Assist technology, or QAT. Now, Quick Assist technology is one of my favorite accelerator projects at Intel. This is not the first time it's been brought to market, but it is the first time it's been integrated into the CPU directly. Now, Quick Assist technology is an encryption and compression engine, and it's very, very powerful. So if you consider an unaccelerated workload, say for level 9 compression, which is, I think, a popular style of compression, one CPU core on 4th Gen Xeon can do the work of 1,000 unaccelerated cores. If we look at encryption to support a VPN, for example, one CPU core can now do the work of more than 4. So we can just radically accelerate these workloads. And it's even a little bit more exciting than that. If we can make compression and encryption incredibly cheap and incredibly low power, then think about the follow-on savings of data lakes that are now shrunk by 2/3. Think about how much more network bandwidth can be freed up by using compressed data everywhere. So we believe that we can pretty much compress and encrypt everything cheaply with very low power impacts. One of the examples from the networking world is the ability on Nginx to make connections 50,000 per second with 84% fewer cores. Just one example of what you can do with QAT. When I get up in the morning and I go to work, I turn the lights out, before I leave because I don't want to burn the power. It's just kind of the responsible thing to do. If you're going to encrypt or compress something and you're going to do it without acceleration, I don't even think it's responsible anymore. The results of these kind of technologies are so strong. Next, I wanted to dive in a little bit into AI workloads. Now, Intel Xeon processors are a really common choice for inference applications. And we've invested in acceleration of inference for some time. You may recall the 3rd generation Xeon had the VNNI technology. Before that, we had the AVX 512. Now we've deployed the advanced matrix extensions, or AMX. And this is a much larger investment in acceleration, and the results show it. So we have a 6 times improvement in performance on recommendation engines. And recommendation engines, some of the most important AI workloads, especially important for the business models of many of our customers. And the performance is getting so good that you can actually start to really look at the CPU as a serious alternative for training. And the training performance is 4 times better on recommendation engines. And the CPU is a nice solution for training because if you're not doing training all the time, you can use the general purpose machine for other activities. So if you're training on Monday, you can be doing inference on Tuesday or database analytics on Wednesday, and so getting the most value out of the hardware. So it's a big step up in capability, and I think very, very valuable to us. With that, I think you're probably all used to folks coming up on stages and talking about big performance numbers. I wanted to introduce you to a colleague of mine from Fujitsu so we can talk a little bit about the real-world experience. So let me introduce to the stage Udo Wirtz. Udo is a Fujitsu fellow. Intel and Fujitsu have been working on data center technologies literally for decades. Udo,
Hello,
welcome.
Zane. Good to meet you.
Good to see you. I understand this is your first CloudFest as well.
CloudFest, but my wife told me yesterday that I was here 2015 when Steve Wozniak here was on stage. And also Snowden was...
before it was rebranded.
Sorry?
Before it was rebranded.
Before it was rebranded, yeah.
All right, well, why don't we have a seat and talk a little bit more about this. I don't know how many in the audience are aware of it, but Fujitsu has been developing an innovation platform called the DX platform, and based on some of these technologies. And what it can really accomplish for customers and end users is pretty remarkable. And I thought, Udo, maybe we just start by telling the audience a little bit about your DX platform and what it can do.
Sure. So the DX Innovation Platform is a hybrid infrastructure, allowing customers doing testings for AI and container solutions they are targeting for before they buy the infrastructure itself. It's located at the internet backbone at NTT in Frankfurt. It's one of the largest one on this planet. And it's free of charge for customers and partners. So when you think about a solution that you would like to create and bring on stage, the question is always, what's the right infrastructure that you need for training, for inference, What about storage I/O and all of those components? And this is exactly what we are serving with this type of infrastructure. As I said, free of charge, and you can use it as long as you want. It's not a cloud service. At the end, it's really a hybrid solution, because when we think about AI training, very often the cloud is not the best solution, as it could be very expensive over time, and therefore we see a demand for hybrid infrastructures in this respect.
That's fantastic. Can you tell us a little bit about some of the customer experiences and what it's really like on the ground, where the rubber's meeting the road?
Yeah, of course. So I brought with me one example, with a real-life example, where we have done all of those testings also with the Intel Xeon 4th generation platform. So it's Aspinac, so they're operating highways in Austria, and everything is changing now, right, in the direction of electric vehicles and electric mobility. And now when we are here in the European Union, and we are now facing more and more regulations. What about charging stations? There is an upcoming regulation saying every 60 kilometers has to be charging stations. You need the prediction for this, so what the expected charging rate will be. But first of all, you have to count electric vehicles on the highway. What's the travel distance? How many of them in percentage in comparison to standard cars, and so on and so forth. So what we had to do is we had to think about a solution where we can identify electric vehicles. And in Austria, as an example, this is given by the color of the characters of the number plate. It's a green color, and they also have an emblem on it, which could also be green, so it's pretty tough. And then we think about also night situations or weather conditions, when we have fog or rain and sunshine and so on and so forth. So, and then we thought, what will be the right infrastructure to serve this? And we have chosen Intel, and the reason for this is the following. So first of all, the question is, how the final solution will look like. Will it be an AI edge grid, which will spread across the country, where you have maybe multiple thousands of devices serving all of those cameras? The customer is running a huge amount of several thousand cameras across the country. Or will it be a centralized infrastructure in a data center? So every server has to start with a CPU, right? And we decided to go ahead with the Intel approach. Also due to the fact that you have done a great job with OpenVINO, with the integration of the advanced metrics extensions. So what we have seen there, we were really able to detect number plates even if the angle of the car was not really perfect. So when we have done the standard testings with YOLO, TensorFlow, and so on, we have seen on our window that sometimes the number plate recognition was not that good. And now with the new OpenVINO release from September 22, it worked perfect. So, and then we have done those recognitions of the images. And we started with the Gen 3. And we achieved 30 recognitions per second.
That's not too bad.
It's okay-ish. So it was good enough to go ahead with the POC, and also with the idea using Intel, also because of energy consumption, also because of environmental, so cooling needs, etc., especially when we think about edge devices. You also said in the beginning, edge is a big topic. And then we have done the testings with Gen 4. And we have done the testings in January exclusively for this project. And I'm really not a marketing guy of Intel, guys, really not. But we have achieved with two cores with 56 streams and a batch size of 1, which means we are recognizing one image. We achieved a recognition rate of 5,000 images per second. 5,000 images per second.
I said it with 6x faster.
Yeah, 30,
and this is a lot bigger than that.
Yeah, I was wondering. No, there's one flip side maybe. So what we have done is we took a portion of 9,870 images, and then we said, come on, Gen 4, what's your recognition rate? And then we achieved those 5,000 images. Now you can think, okay, when we have an edge device, the edge device is serving several cameras, we have to take the frames out of the video stream. Maybe this takes also some time. Maybe it's not 5,000, maybe it's 2,000 or 3,000 images per second. Come on, guys, this is more than fast enough for inference. No question about this. And this gave us really the proof point that this really makes sense. And this is possible because of the acceleration. And I think From my personal point of view, saying this is Gen 4 versus Gen 3, this is just a number. But it's really a game changer, because with the accelerators on top, where you can do the AI stuff, the HPC thing, the 5G thing. Also, Fujitsu is playing a major role in 5G. We are the world market leaders for radio units, as an example. When we think about Open RAN networks, where we have disaggregated infrastructures, which will also become a very important topic for the data center over the next years, by the way. This is where we see a lot of improvements with the Gen 4.
Oh, that's fantastic. And to see it already in practical applications like that is really exciting. So if we're so fast now on inference, what about training? Do you think training is the next step?
Yeah, so if you would ask me for the versions before, I would say, well, I don't know, let's go for an accelerator. With Gen 4, this is, as I said, it's really a game changer in this respect as well. And I call it the democratization of AI, because when you buy a server with a CPU already installed, which is capable to have dedicated AI acceleration in place, and in the customer engagements that I have, I see very often customers are targeting for small, maybe mid-sized models when we are finalizing the training. And we have seen that I think it's 10 times faster than the Gen 3, what we have seen so far with PyTorch as an example. And when we had a training in the past with the CPU for 10 hours, now it's 1 hour. It's, for a lot of companies, that's more than good enough. And you can start right away using this infrastructure that you have already in place. And if your model works and if the AI solution works that you are targeting for, okay, then you can do the next step. And then you can think about how can I improve the performance when the data sets are getting larger, as an example. One idea could be to have some trainings in parallel. This is possible, Horrorwood and all of those solutions as an example. Or you can go for an accelerator that you also have in your portfolio. So I think that's a very good starting point. And this lowers the hurdle, from my personal point of view, for companies to start into their AI journey.
Well, that's fantastic. I think the AI world is just growing and getting so big, and there's so many facets to it that there's not a one-size-fits-all, and so there's a big opportunity here, I think. Final question for you. So my focus in this whole talk has been about energy efficiency and facing climate change and stress on utilities and everything else. Do you see the same kind of concerns from your customers, and what kind of conversations are you having with your customers about energy efficiency?
Yeah, of course. So Fujitsu is also dedicated to those CDP lists and so on, achieving highest rankings and all of those bullet points. The thing is, of course, energy consumption is a big topic, especially here in the European Union. I'm here from Germany, and we have one of the highest prices for kilowatt per hour, even for the mass hosters. So it's also expensive for those guys. And therefore, saving energy is a big topic. I think now with the Gen 4, where we have all of those accelerators, I don't want to repeat all of them again, but it's really that you can be more flexible in terms of the workload. In the past, everything was about speed, right? So higher clock frequency, I don't know, more cores and all of those things. And I don't believe that this is the right way forward. I really believe that having a CPU in place where I can switch to VDI, tomorrow the customer has a different demand in terms of 5G and virtualization, or he needs a better storage I/O, and then I can really improve it with the same hardware. And I don't need additional infrastructure elements, which makes it more complex. I have to operate them, I have to maintain them, I have to install them, doing all those investments, etc. And this gives us a much more better flexibility and, of course, energy savings.
Fantastic. Udo, thanks for the partnership and thanks for coming on stage today.
Thank
really
you.
Appreciate it. Very enlightening.
Okay.
Thank you.
I enjoyed the show. Cheers. Thank you.
So I hope you can see that these directions actually are really practical and they're already having an impact today. The 4th Gen platform is ready to go. We are shipping in high volume today. The whole ecosystem around it has been enabled. We have over 450 designs based on the 4th Gen Xeon processor. 200 of those plus are already shipping. All of the major OEMs and ODMs have systems. The top 10 global CSPs are deploying. So this is available here and now. I do hope everyone here takes the message to heart that together, we really do have to partner and bring the innovation that this ecosystem is capable of to hit new levels of energy efficiency. And we need big gains, not just small gains, not just little incremental steps, but some big ones. And maybe it's actually worth working for. And I know that if we work together, that we can do it. And a lot of people are working with us on this vision. I'd just like to call out quickly our partners. If I can get the slide to change. We have a number of partners here at the show talking about 4th Gen Xeon solutions and what they're doing to build on top of this technology. Please give these guys a look. Moore's Law, we're going to keep it going. We're going to continue to innovate, making data centers and edge deployments more energy efficient. And we're going to keep working on acceleration and other forms of hardware-aware software. I think if we do all of that, we can keep this energy efficient track record that we have as an industry going strong. Thanks for your time today. Have a great show.
Thank you so much, Dr. Zainbal. You have spent a lot of your career really focused on the high efficiency within the energy space, and I read in your bio that you've got 6 patents in high-speed electrical design. You've been working
It's been a while, but yes, absolutely.
You've been working towards this, if you want to join me up here. You've been working towards this for some time, so excited to have you share. If there's one thing, I know you mentioned, partnerships within the industry, it's the one thing to take away from today's talk.
The one thing is that hardware and software have to work together. And that if we have hardware and software working together, there's tremendous resources in hardware to really change the game on energy efficiency. But it does require effort. It does require a little bit of investment. In the end, it does save everyone money, by the way. I didn't mention TCO, but in the end, it actually pays for itself. But we have to do the work today to make it happen. And I couldn't be more excited about that.
Wonderful. Well, thank you so much. And as one of our Diamond Plus partners, Intel being here on stage with us this morning, appreciate your time.
Thank you.